right, so let's talk about the cellular network and how you get mobile device forensics, which is, of course, a really big issue. In fact, probably the most important thing. If you think about something like a crime scene, everybody has cell phones, and they also have computers, but probably the cell phone is the most important source of data for most purposes because it knows geographically where you've been, it has your photographs, it has your emails, your instant messages. If you want to know what people have been doing, the cell phone is probably the most important thing. And as far as making cell phone calls, which is only a small fraction of what modern smartphones do, you have the mobile station, which is the mobile phone and its SIM card, which uniquely identifies it. Then it goes to a base station, which has got a couple of things like a transceiver and a controller and a station. This is your local tower, and that goes through the network, the mobile switching center that moves through cables across the telephone network and eventually gets onto the public switch telephone network, which is the original one, the one that carries telephone calls to the other phones. And so the base transceiver is what you see here. This is the towers are controlled by the base station controller. Each one of these antennas makes a zone that can only carry a certain number of calls, like 40 or something. That's why they need so many antennas. And the total number of calls is limited by the number of antennas they put on the pole. And so when you move your phone does a sort of handshake to find the nearest tower and sort of log in with the nearest tower, because the phone company needs to know where your phone is at all times to ring the phone. So I dial your number, the phone company says, where is that phone right now? It sends a signal to the nearest tower, which is associated with your phone, which then rings the phone. And that's why if you subpoena data from the telephone company, they know where everybody is all the time, but not with great precision, only to within maybe 100 yards, because they know which tower they're associated with. And as you move, your phone notices this signal is getting weaker, but another signal is getting stronger, and it does a handoff, or lets go of this tower and connects to that tower to give you continuous connectivity, unless you go through a dead zone where there really is no cell phone service. So that's called a soft handoff, as it goes from one base to another.
Is the antenna the cell?
The antenna, the what?
Is the cell, is the antenna, each antenna is the cell?
Each antenna, I think they call the cell the region it can reach, which is like 100 yards, and the group of phones that have connected to it, which I say is not that many.
Because in the jargon they say that your phone is connected to a cell.
That's right. Yeah, each one of these antennas makes a cell, and you join one of those cells. And then as you move it around, you let go of that one and join a different cell. So they know which one you were connected to, so they know approximately where you are, but not with great precision. And so that's an important part of evidence. They can get that information. And then, of course, the other thing they can get is they can get the pen register. And the pen register, this is what it is. It's basically the information you used to get on a long-distance phone bill. It is the time, how long a phone call was, who called who. That's all. And they don't get the contents of the phone call. They don't hear the actual voice. Now, that's a wiretap, and they can do that with a wiretap order. But usually all they want is this. This is enough. This tells you who's talking to who, so you can find out who's in the gang. In fact, this is what they typically use to capture gangs of any kind. What you do is you have a group of people, you suspect them of being in some criminal gang, and so you arrest one of them, and then you watch the pen register, because the other ones will call the rest of the gang and warn them, oh no, they're busting us, they're arresting us, and see whoever they call. And just by knowing who called who and what time, you can get a pretty good idea who's involved in the gang. So that's a game. All right. And you can request these records to be preserved for 90 days, and they can extend it 90 days at a time with court orders. So you can get subscriber information, which is, of course, the cell phone company, if you subscribe to their service, like T-Mobile, they know more. They know your credit card number, your address, your real social security number, and so on. Call detail records, or what you see up here. And they can also get PIN unlocking codes to bypass PIN protection. If they actually physically get your phone, they can get a PIN unlocking code to get the data stored on the SMS card, and that contains all your SMS messages and other information stored on the card, sort of like a hard disk. So that's a general overview of the kind of data the telephone network has. So the mobile station is the handset and subscriber identity module, which is typically a SIM card. That's the SIM card here, which contains the specific, that's why you can pull out the SIM card and plug it in a different phone, and now it'll recognize that other phone as your current phone and take phone calls there. So it gives you your IMEI number that uniquely identifies the handset. So there's also a UICC card on a GSM network, a different version, which sometimes it's a SIM card, otherwise it's the USIM card. And there's a thing called a mobile equipment identifier for CDMA devices. It's pretty complicated. There are 2 or 3 different kinds of cell phone calls with different kinds of towers, and they all amount to essentially the same thing, but there's a unique way to identify the handset and the customer. Right. And one of the things you get is it's typically locked. As you know, you typically sign a contract for 1 or 2 years with one carrier like T-Mobile, and then your phone is locked to that carrier, and you can't move it to another one until the contract expires. Now, as far as I understand, I think Obama ended this years ago, where they can't force you to keep your phone locked to one provider. It used to be illegal to unlock it and move to another provider. Now I think that is legal, although they try to prevent it. Anyway, so all U.S. phones have an FCC ID indicating it's authorized to run on radio frequencies within the Federal Communications Control. All radio devices in America have to obey FCC rules. You're not allowed to make too much interference because it would interfere with other devices trying to use the radio network near you. And so that's the FCC ID there, which I think just says your phone has been tested and proven not to put out too much radio interference. So the SIM card is where a lot of data is stored. And IMSI is another international unique number. First 3 digits tell the country code, and there's more details as you go down. That's this long number here. So when you connect, okay, so Mobile Switching Center takes user information that it gathers from the phone, and it passes it to the home location register, which shows who's actually a subscriber, and the visitor location register, which is roaming subscribers, people passing by the cell phone network that are not customers of that particular company. And then you got other things like equipment identity register, and there's an authentication center, which issues encryption keys. All cell phone calls are encrypted, and they're pretty strongly encrypted. I think it's with 64-bit private key, which is pretty good. And that's why if you want to intercept a cell phone call, you have to do a downgrade attack. You have to make a fake cell phone tower, and you have to offer old service, like you've moved to a rural part of town with really old equipment, so you downgrade from 5G down to 4G, down to like 2G, which is very weakly encrypted. That's what you have to do if you want to break into it. All right, there's mobile network operators run the network like Verizon, T-Mobile, AT&T. A mobile virtual network operator does not own their own network, but they use somebody else's hardware, like Google Fi, or I think the local one here is Sonic. This has been around for a long time. You can make a phone provider that actually uses other people's wires. You sort of rent it from them. Sort of like you can have a web company and you rent the machines from Amazon. All right, and so it's evolved from 2G up through 5G. 2G used time division, multiple access, and I think no encryption, or else only weak encryption. And so GSM is an international standard made in Europe that uses also time division, multiple access. 3G uses UMTS. There are a lot of sort of a wild alphabet soup of all the different versions here. There's code division multiple access, which is a spread spectrum communication methodology using many frequencies of radio. And there's integrated digital enhanced network as a Motorola one, IDEN. So there's a lot of these things. Anyway, the point is there's an interface to communicate with the device. That's this thing. This flat thing makes an electrical connection inside the phone on the SIM card. It goes into a little slot like a floppy disk, and it has storage on the SIM card. And so the SIM card is where the storage that you most want to get at is there. And it's sort of like the hard drive of a Linux computer. It's got a master file, root, and directories of files and elementary files data stored. And EF is what we want. That's where subscriber information is stored. So you have contact names and numbers, and you have the cell phone networks it has been attempting to connect to, but didn't get authorized to. So that is as it tracks your physical location, all the towers you've been trying to connect to. Then it has the last number dialed, a list of outgoing calls made, and temporary identifying numbers, and the SMS messages on here. So you have, these are your instant messages, and these are the calls, and here's a record of your physical locations. This is all extremely useful, and that's all stored on the SIM card. They're PIN protected. You have to put in your unlock code to get in, and you have 3 attempts to get it before it's locked. If you do try 3 times and don't get in, then it's locked, and you're going to have to get a PIN unlocking code from the carrier, which you can get if you can get a court order requesting that. So if you are the police or an authorized party, those codes are available. And you can clone the SIM And you can do it with a variety of software tools. But the data you get will be encrypted unless you can unlock it. So you can now see whether an SMS message was read, deleted, unread, sent, unsent, so on. So all that information is on there, just like emails. And MMS are the multimedia SMS messages that might contain videos and images. And you can carve them with forensic tools like Encase. And the rich communication services are another one, like WhatsApp and Signal. They maintain the same legal intercept standards. This is something that the maker of Pavel Durov, the maker of Telegram, started a big scare about a year ago claiming that Signal was not properly encrypted, which made Moxie Marlinspike, who invented it, very angry. Signal is as well encrypted as you can possibly do, because he said if you get the end user's device, you can find the messages on there. He said, well, obviously, you wouldn't be able to read it if your end user device couldn't decrypt it. It's as encrypted as it can be, but it has to be decrypted at the end, or nobody could read it. So there's no way to improve on that. The thing about Signal is it really is encrypted end to end, so everybody in between cannot read it. Your carrier at the other end, it's all encrypted until it reaches the end user's device where it's decrypted. So if they get your phone, they can read those messages. But in the middle, they can't. All right. And so the operating system on the smartphone, it's basically just a small computer. Usually it's Android. It's Android or iOS. And they're both essentially Linux. Android is based on Linux. iOS is based on Unix, which is almost the same thing. So Android is, here's what you'll typically find on Android. You have the boot code for the device to boot it up. And there's a system that contains the Android operating system and recovery, stores a recovery image. If it cannot boot up, it can try to open a limited recovery environment to repair the system, temporary data in the cache, and MISC is used by recovery process. But normally the only thing you care about is data. This is where all the user data is stored, the emails, the photographs, the SMS messages, all the information saved by all the apps. Each app has its own folder in the /data, so Signal has its own folder and your email client has it and everything. This is what you usually want, and when we do the forensics projects in this class, you're just going to see all I have is the data partition to analyze. That's where all the good stuff is. All the rest of this is the operating system, which is not usually very interesting. That's just standard files from Google. It doesn't have anything personal to the user. And your applications are APK files. When you download it from Google Play, you get an APK file, which is just a zip archive. Then you unzip it into a folder, and for some reason, I don't know why, they store the original APK on the phone along with the unzipped version you're using. Now, if you install software on a laptop, you download the installer, you run it, and then you throw it away because it's just a waste of space. Your phone does not. It keeps the APK around. I don't know why. It seems to me like you could throw it away after you install it, but they don't. It's in there, which is handy if you want to audit a phone. All you have to do is install things on the phone. You can suck them off the phone with Android Debug Bridge and analyze them in another virtual phone. We do it all the time in the mobile device hacking class. It's handy for that purpose. It must serve some other purpose. I don't know why they keep an extra copy of every app in, but they do.
And the apps are Java-based.
Yeah, now some of them are technically native code, like C or C++ compiled, but on Android, almost all of them are Java-based. That's the most easy and most common language they're written in, and that means they effectively have the source code. Because when you compile Java, it doesn't compile down to machine code, it compiles down to an intermediate language called bytecode, and that preserves all the labels of the variables and routines and methods, variables, and so you can easily read that. It's almost the same as Java code.
Right, but that prevents also the reverse engineering, because I think, right. Okay.
No, it doesn't prevent it. It makes reverse engineering very easy. That's why we do a lot of it in the Android device hacking class. You have source code. You can just read the source code. That's why when I audited hundreds of Android apps, and I found that very many of them stored your secrets with reversible encryption, and then they tried to hide the key on the device. And you can just read the source code and find the key. It's obvious that the developers do not understand how easy this is.
I'm so convinced that they did something, either they delete some files in order to prevent the reverse engineering.
There are ways you can obfuscate it with products like Mach-O, or I think Dash-O. Dash-O is one product, and there's also something Google provides called ProGuard, which is supposed to obfuscate it by removing the symbols, but in practice it does nothing. It takes some of the routines and changes their name to like A, B, and C, but in practice, I've audited hundreds of apps. I'm always easily able to find credit card numbers, passwords, and other secrets. The free product from Google makes it look like your thing is obfuscated, but it doesn't actually obfuscate the important information. It's amazingly ineffective. There are commercial products that do a better job. They change every variable to like 10 random characters, so you can no longer search for password, but you can still find it. All you have to do is use Python to add extra code to all of it to log everything, and then run it until you put in the password and you'll find out which variable it is. But it's more tedious, so it makes it a little bit more difficult. But it's always much more easy than it is to reverse engineer compiled C code, native to Windows, or that kind of thing. Yeah, very good question, very important issue. So then you have the issue of evidence accessibility. So typically the data is encrypted. Every iPhone after the iPhone 3 has everything encrypted all the time, and the higher end Androids have encryption turned on all the time. The cheaper ones sometimes don't to save power, but it certainly should be encrypted. And so then if you don't have the password or PIN, you're not going to be able to get the data. It's encrypted with AES typically. You're not getting in there unless you find the PIN. So you can get the data with physical imaging with a device like Cellebrite, which is just a device that will connect to the phone and download all the data, but you still need to unlock the phone. Although Cellebrite claims to have hacking codes that will hack into every version of Android and iOS if you pay for it, at least up to a couple versions back. I'm not sure they have the very latest version, but I think they do. There's two companies that specialize into hacking it. There's Cellebrite in Israel, and there's Elcomsoft in Russia. And both of them have a team of experts constantly finding flaws in every version of Android and iOS and finding a way to get past the pin. So if you pay for their software, you can usually break through anybody's phone. But it's only available to law enforcement typically. And you'd have to have, I guess, the latest version of it. Anyway, so otherwise you copy the data off the phone, but it's still encrypted, so it's not doing you any good. Unless you can somehow get the PIN, or if the user used biometrics, like a face or a fingerprint, then you can force them to reveal that. You cannot force them to reveal a passcode or PIN because of the First Amendment, which says you have the right not to speak, and because of an issue involving the Pledge of Allegiance about 40 years ago, they decided that you also have the right to stay silent. So you are allowed to not answer a question, and so you can't tell them, but if it's your thumbprint, you don't have the right not to give that up. So, all right. So JTAG is a Joint Test Access Group, is a standard for the maintenance of assembled circuit boards. And so JTAG is a chip. You can get a JTAG chip and you can connect to the hardware on any mobile device and suck the data off. And this is what you do to break into all the portable Internet of Things devices, smart light bulbs, smart cameras, GPS units. They all have code in them, and you attach this is also how you recover a bricked device. If you start playing with the firmware on your router and replacing it with alternative versions of the firmware, that's fine, but if you have a flaw transmitting the new firmware up there, you can brick your router where it won't even boot up anymore. And the solution is to put a JTAG chip on it so you can manually put data back in the memory chips. And this works for phones and any of Internet of Things devices, and this is why I wish we had an Internet of Things class, a mobile device hacking class. As Liz is an expert in this. She does it, car hacking at the CTFs and all that, and she could be teaching that course. Hopefully we'll have her back next semester. But I mean, that would be great. I've been wanting to have that course for years, but because of all the budget and staff cuts, we haven't had it. But this is what you do. You use a JTAG device because when in the factory, they can put firmware on the device and modify the firmware and have different firmware versions, and they'll have some way for you to do like a firmware upgrade. But if you want to put unauthorized firmware on the device, that's often difficult. And typically, you do it with the upgrade process, which requires the thing to be working. So if you break the firmware and it won't even boot up anymore, there's no way to fix it in the original hardware of most devices. But you can add a chip that lets you reprogram the memory chip, and that's the JTAG chip. And this is what you often have to do to break into an Internet of Things device. You have to add an extra chip to it and then suck the device off. Although what most people do in practice is they just find a copy of the firmware on the web somewhere and download it from there. But they do encrypt and obfuscate the firmware on the web to try to slow down reverse engineers, and There are a lot of people talk about that. So if you don't have something like Celebrite or it doesn't work, then you try JTAG. And if that doesn't work, the last resort is chip off. They can do this at Drive Savers. You take apart the phone, you take apart the circuit board, you pull off the chips, and you take the data out of the chips one by one. Then you can get every bit off the phone, and you'll have to reassemble all those bits. It's like 8 layers, and you have to reassemble them. It's amazingly difficult, but they do this at Drive Savers. They have a clean room with the vacuum pumps running, and you wear a bunny suit, and they have a whole wall with a model of every hard drive in the world, and they can do chip-off forensics of hard drives and probably other devices by now, but their main focus has been hard drives and SSDs, because the most common thing they have is somebody has a laptop and it won't boot up, or it's broken, or it got in a fire or run over by a truck, and they want to recover the data from that thing. And they can almost always recover it by taking apart the storage unit as necessary and replacing components with components from an identical good one until they get it working. And they can even do chip-off forensics, taking the chips completely off the board and reading the memory off them. It's expensive and complicated, but if you really want it,
So it's
they
like
can do it.
composing a puzzle at that point, right?
What's that?
It's like composing a puzzle
Yes.
at that point, because if it has damage.
Yeah, but they can recover a lot of data, even from things that have been like buried in a lake for a year. For almost anything, they can get some data, or often all the data off it. But it's expensive, as you would imagine. Yeah.
Okay, well, if there is the possibility.
Yeah, if you really want it, the chip off is your last resort. Actually take off the chips and suck the data out of them one by one, and then reconstruct the data. All right. Then there's in-system programming, is when you connect to a memory chip to access the files. That's less invasive. There's also sometimes emergency download mode available, a technical recovery feature where you can reboot into here and you can forensically image the device. I know on there's a thing called target disk mode on Apple laptops where you can use it as a hard drive instead of booting up the operating system, and then you can copy the data off it. That's sort of similar thing here. So Androids are secured by a PIN or a password or a pattern lock with a gesture or biometrics, as we say, face print or fingerprint. Typically one of these is how it's secured. And there's a lot of tools to perform forensics on Android. Once you have gotten the data off of it and you've unlocked it with the PIN or passcode or something, then you just have to organize the data like we're going to do in autopsy, where it just finds the data and sorts it into emails and images and such. Now, you can typically do it with a USB cable. If you can get the operating system to run and you have the login, then you can turn on ADB mode. And ADB mode lets you control it through the power plug. You connect to a computer, and that's Android Debug Bridge. You can now connect it through a USB cable to a computer, and from that you can read the data on the phone and copy it. That's how we do everything in the mobile device hacking class. All right, and the applications, of course, contain a lot of useful data. The applications typically have a database in them, a SQLite database, and the apps are written in Java. So every time you see a Wi-Fi hotspot, it's recorded, and you can map out your physical location from that, in addition to the cell phone towers. And you'll find all your chats and contacts and photos and emails and everything in there too. Facebook messages and everything else. One issue is, how can you preserve mobile device evidence? One big issue is, if you get a phone, it's receiving signals from the cell phone network all the time, and possibly from Wi-Fi networks, and so it might be receiving new messages, changing the data, and it might even be receiving a wipe code. If it's a device, a managed device, the criminal or the boss might be sending it wipe code. So when you seize a phone, the first thing you want to do is disconnect it from the wireless network. So you put it in a Faraday bag, or a paint can works too. You put it in some kind of container that blocks the radio. Now, this is the standard technique. You seize the phone. Now you connect it to an external battery, because when you put it in the paint can, it will lose connection to the tower, and it will turn the radio up to the maximum power trying to reach the tower. So it will drain the battery faster. So typically you connect it to an external battery, you stick it in a paint can, and now it's okay for quite a while. Now you can transport it back to the lab. That's why there was a news article last week, I didn't bring up here, but I used my links, where some forensic examiners are very upset because they seized iPhones in this manner, they took them back to the lab, and the iPhone rebooted. They had it unlocked, but it rebooted, which locked them out because of the PIN, and they say they have not proven this, but they believe with the very latest version of iOS that came out just a couple weeks ago, they think Apple has added a feature where if it can't reach the cell tower within 24 hours, it reboots. And if that's true, that will require a different procedure for forensic examiners. It'll be you must image that phone within whatever that time period is, 24 hours, in case that happens. But it might just be something strange about the few phones that reported this, but that's freaking people out. The people on the latest version of iOS have a new concern they have to consider when they're trying to decide when to image the phone.
Implies a back-in-time procedure, like for example the Mac has, or just locks the phone with the password that.
Well, see, there's several different levels of unlock on an iPhone. One, you can have it totally logged in where you can see everything. Then if it's totally powered off, then everything is locked. And if you find it when it's asleep, but it can still receive a phone call, then quite a few things are unlocked. And that's what they like. They had it in that condition, but after it reboots, it's back in the other condition where everything is inaccessible. That's why they were very upset. Yeah. All right, so that's so you validate your tools. This is a general thing for all forensics. You're supposed to do a measurement to make sure your tools meet certain standards, sort of calibrating them. There's various techniques here. And all right, so you be aware of this. Therefore, when you secure the scene, first you ensure the safety of individuals. You make sure there's no more criminals in there with guns running around or anything. Then you put up that crime scene take. Then you document it by taking video or photographs of everything. Then you collect the evidence. And you want to preserve the value, so you isolate the mobile devices from the radio networks so they can no longer receive any signals from the outside. You package them up and then take them back home, maintaining chain of custody. And so you remove it from the network with a Faraday box, like what you see here, or Faraday bag, or they say a paint can is fine too. And then after you clean the paint out, of course. And then it requires frequent charging because it's going to drain more rapidly. Once the phone shuts down, then you're going to really need the PIN to get any of the data. All right. And by the way, you might wonder why they don't just jam the cell phone signal, and you're not allowed to. Jammers exist. You can buy them, but they're illegal. They're illegal to use almost anywhere. Years ago, movie theaters tried to use cell phone jammers to stop people from getting phone calls during the movie, and they found out in America it's illegal to jam it anywhere because somebody might have an emergency. They might need to call 911 or something, and you'll be legally liable for blocking that. It's illegal, so nobody's allowed to have signal jammers. Not even for this purpose. So, all right. All right, so here's some tools. GrayKey is something available to law enforcement that can bypass pins. The old ones I heard of, I don't know if the newer ones are better, they would just connect to an iPhone, and you could have 10 guesses before it locks out. So they would guess 9 times and then reboot the phone, and guess 9 times and reboot the phone, and eventually they tried all the pins. At least for 4-digit pins, they'll get in. Now with the modern 6-digit pins, this might be less practical, but they might have a new version that somehow does it better. BitPim is another tool to manipulate certain phones. Mobile Edit Forensics is another tool you use to extract data. E3 by Parabin is one of the famous companies that makes cell phone data acquisition and analysis tools, and Cellebrite is the most famous. And these are very expensive to get the latest version of these things, and you often get like a whole suitcase full of adapters and kits and everything to get in all these phones. It can be very expensive. All forms of forensics tend to get very expensive. So computers and mobile forensics, there's an issue with file fragments, but as I say, phones use SSD storage, so typically there is no latent data. You typically don't get anything in the way of deleted files. It's possible you can resurrect some deleted files with like physical extraction, like chip-off forensics, but mostly you're only going to get active data. Now, if you don't have the right equipment to do all this complicated stuff, you can still get some evidence off the phone. And you remember, evidence collection does not have to be perfect. The perfect thing would be to have the right device, suck every bit off the thing, analyze it in a tool like Autopsy. But if you don't have that, you just get a rig like this where you just put a camera up here and you just take a picture of the face. And then you page through the messages and take a picture of every message. That is evidence that came from the phone. Remember, the real evidence is the human examiner going to court saying, I went to the crime scene, I seized the device, I looked on it, and I found this SMS here. That's what really matters. It doesn't have to be a perfect electronic process that gets everything. You just have to have done something that gathers evidence from the device, and you have to be able to explain it in court in a convincing way. So this is an option. If you don't have the right gadgets, or it's an emergency, or for whatever reason you don't want to do it the fancy, perfect way. You use whatever tools you have, and you get some evidence. And so you need a warrant for the cell phone these days, but there are exceptions, of course. If you get consent from the owner, then you can examine a phone. Or if it's part of an arrest or exigent circumstances, if it is some kind of emergency, like I have reason to believe there's a bomb going to go off, then you can ignore all the rules and seize the evidence. So if you get a warrant, then it has to describe the cell phone, include all the information about the phone, and let you know what type of evidence you're going to get, SMS, MMS contacts, and so on. Just like any other form of computer forensics, your warrant will say what you're allowed to do. So that's the summary of cell phone data. Let me stop this.